Hi, I'm Alex Vocht, and today I'm going to present to you my research paper on procedural content generation, but more specifically, an iterative segment-based approach for generating Mario levels using experience-driven reinforcement learning. And today, my little friend Mario will be helping me present.
It's me, Mario!
So what is procedural content generation? It's the automatic generation of content, and it's widely performed in the context of video games. It can be used for creating a variety of things in video games, such as maps, sounds, weapons, and even storylines. But why do we even care about this generation of content? Well, in recent years, the demand for increased content in video games has skyrocketed, and having the ability to procedurally generate this content helps video game designers keep up with this increased demand. In fact, it's already been used in a wide variety of games, one such being Bad North by Raw Fury. But now the question is, how do we build a good game? And what do we consider to be a good game? We will consider a good game to be one that has fun and diverse levels. And we can build these levels through experience. This is done through reinforcement learning, where we break levels into level segments and look at previous level segments to determine the quality of the current segment. We will need to quantify these ideas of fun and diversity. But how is this even done? Let's first tackle the idea of what is considered to be fun. If we consider Coaster's theory of fun, which states that if patterns in a level are too similar, the level can be considered as boring. And if the patterns in the level are too different, the level will be considered to be overwhelming or challenging for a player. And now for tackling diversity. We want level segments that are unique and interesting. And tile pattern KL divergence helps us quantify both of these things. KL divergence allows us to compare distributions, but tile pattern KL divergence builds on this by allowing us to compare the distributions of patterns. We will need a way to train our agents to accomplish all of these things. In order to do this, we will need to formulate our problem as a Markov decision process and create a framework. We adapted upon the PCGRL framework to incorporate experience-driven learning at an iterative segment-based level. Our agent is tasked with changing a single tile in a presented level segment. This changed level segment is then compared to earlier completed level segments. And then we take these comparisons and provide our agent with experience-driven rewards as well as optional other rewards. And then we train our agents using the PPO algorithm. All of our agents were trained with a variety of combinations of rewards, as well as being given experience-driven rewards in a sparse and dense manner. After we did all of this training, we analyze how well our agents performed. In particular, on this slide, we are looking at whether or not our agents created a fun level or not. We do this by finding the average KL divergence, tile pattern KL divergence between the level segments in each of the levels our agents generated. If this average falls between the bounds of what we consider to be boring and overwhelming or challenging, we can then say that our agent can create levels that are fun. Similarly, we analyze our agent's diversity skills. We do this by getting the average SSIM score between all the level segments across all the levels created by that agent. What we consider to be a good level of diversity is when the average SSIM score falls below 0.5. Our fun and diversity results are summarized in the table provided. We can see that majority of our agents were able to produce levels that are both fun and diverse. In fact, our agents were also robust enough to be paired with a variety of other rewards and deal with different types of reward allocations.
Mamma mia!
I know it's impressive, right, Mario? Next, we want to see how our agents performed at producing levels that are similar to the original Mario levels. We do this by looking at the correlations between the distributions of all the level segments. This was accomplished by reducing the level segments into XY coordinates, and then clustering these XY coordinates to find which agents produced levels that are similar to that of the original Mario levels. We can see that quite a few of our agents were actually able to accomplish this. It's worth noting that our agents took an extremely long time to train and generate levels. This means that we could not do as much fine-tuning as we had wished, or perform as many experiments as we had intended. Further works range from applying it to different games to more basic changes like changing certain hyperparameters. From this presentation, we can see that we were able to achieve everything we had set out to accomplish. Thank you for attending my Mario talk. Have a good day.